So here we have the same quadratic function. One is written in standard form. The other one is written in vertex form. So in each form, we're going to determine what the x-intercepts are for this parabola. So when I'm in standard form, I actually want to rewrite this function in factored form or intercept form. And I'm going to set it equal to 0 in order to determine what the intercepts are. So to factor this trinomial, since it's x squared, so my leading coefficient is 1, there's like a hidden 1 here, that just factors into x and x. And then here, 5 is a prime number, so this one's pretty easy to factor. The only factors of 5 are 5 and 1. This is positive, and my middle term is positive as well, which means it should be plus 5 plus 1. So when we think about factoring a trinomial where the leading coefficient is 1, we're looking for two numbers that multiply to 5 and that add up to 6 to the coefficient of x, which works here with x plus 5 and x plus 1. So if I went through and I redistributed and I actually multiplied out x plus 5 times x plus 1, I would get this trinomial again. Okay, so I factored the trinomial into two binomials. So if one of these binomials was equal to 0, that would mean I was multiplying 0 times whatever this second factor is. And 0 times anything is 0 because of the 0 product rule. So that means if one of these factors is equal to 0, it would make the entire function equal to 0. So I'm going to create two separate equations now. One where x plus 5 is equal to 0, one where x plus 1 is equal to 0. So to solve for x here, I would just subtract 5 on both sides, which means if x is equal to -5, that's one of my solutions or roots for this quadratic, and that means the x-intercept, one x-intercept, my parabola, is -5. For this one, if I just subtract 1, then I get that x is equal to -1. So these are my two roots or solutions. And it tells me that x-intercepts are occurring at the points -5, 0 and -1, 0. X-intercepts are where we intersect the x-axis, so the y value will be 0 at those points. That's why we set the function equal to 0, or I substituted in 0 for f of x or for y. Now let's look at what happens when I do this in vertex form. So we're starting the same way. We're substituting in f of x with 0. So if 0 is equal to x plus 3 squared minus 4, how can I figure out what value of x would make this equation true? So I'm really just trying to isolate x here. And I'm going to start with what's like furthest away from x. So I'm going to move this 4 over to the other side. I'm doing inverse operations, so adding 4. So 4 is equal to x plus 3 squared. I want to get rid of this square so that I can get x by itself. In order to get rid of a square, the inverse of that would be to take the square root. But I have to remember when I'm taking a square root here, there are two possible square roots of 4. Generally, we think of it as just +2, but actually, it could be +2 or -2. So +2 could be equal to x plus 3, or -2 could be equal to x plus 3. Again, the square root and this exponent of 2, they are inverses, so they cancel each other out, leaving us with just x plus 3 on the right side. Let's isolate x. So I'm going to subtract 3 here from this first equation. When I subtract 3, I get that x is equal to -1. That's one of our answers that we got from the other form. On this side, again, I'm subtracting 3 from both sides. -2 minus 3 gives me -5 is equal to x, which is also what we got using the other form. So either way, in either form, we get the same solutions or the same x-intercepts.